Iran's plan to counter fifth-generation stealth fighters. Modern stealth fighters are designed to delay or prevent detection from higher-frequency radar in S, C, X, and Ku bands, because these bands are capable of providing a weapons-grade lock. In other words, they can guide a missile to a target. Lower-frequency radar arrays leveraging the L or S bands are not capable of guiding weapons with this sort of accuracy but are capable of spotting stealth fighters. As a result, many countries have developed early warning radar systems that leverage low-frequency bands to notify them of the approach of stealth fighters. Yet most countries lack the ability to target these aircraft even when they know they are flying directly overhead. Therefore, to counter a fifth-generation stealth aircraft, tracking at long ranges is the key, otherwise air defense systems will be destroyed before engagement takes place. To be able to track stealth aircrafts at long ranges, powerful and state-of-the-art radars are required, as well as some tactics on the battlefield to significantly increase the tracking range. The Iranians are simulating fifth-generation stealth aircraft by using small-scale jet-powered copies of the F-35 and F-22 to familiarize themselves to some extent with their radar signatures in a potential battlefield encounter. But how does such a process work? The answer is to establish a kill chain under the most difficult conditions, such as massive jamming, cyber attacks, and challenge of facing large numbers of cruise missiles and suicide drones in the first wave of a possible assault on Iran. Establishing and training a kill chain is the foundation for possible successful destruction of fifth-generation stealth fighter jets. Stealth planes are by necessity limited in the type of radar waves they can make themselves hard to catch for. However, as said before, low-frequency, continuous wave radars are very powerful and nearly impossible to hide from. On the other hand, they do a poor job at pinpointing targets. In most cases, they can do little more than establish a general area or a bubble in which the target has to be found. However, modern signal processing and cross-referencing has done a lot to increase precision. These radars are still not good enough to guide air defense missiles, but what they can do is pass on their information to radars which can track and provide target-quality data and hence, guide missiles to the target. Once these radars, ground-based or airborne, have an expectation pattern, they can use all their power to scan a certain area. The main problem for the defender is having enough hardware and real-time secure networking. Therefore, after detecting stealth fighters using low-frequency long-range radars, the Iranians could interconnect multiple mobile high-frequency radars in different bands to intensely scan certain area and so generate high-quality targeting data at long ranges to create a kill opportunity. There are mechanisms for combining signals of multiple radars to achieve increased range, radar sensitivity, and angle accuracy. A first signal beam is radiated from an antenna of a first radar in the direction of a target. A second signal beam is radiated from an antenna of a second radar in the direction of the same target. The echo signals from the first signal beam and the second signal beam are received at both radars. The echo signals received at the first radar are processed to produce first radar processed echo signals, and the echo signals received at the second radar are processed to produce second radar processed echo signals. The first and second radar-processed echo signals are combined to form an aggregate value. This can be of course done with dozens of interconnected radars. Distributed interconnected mobile radars that are easy and quick to set up will make life much harder for stealth planes. Indeed, the Iranians managed to detect 6 F-35 fighter jets using exactly their low-frequency radars 3 years ago after launching a series of heavy ballistic missile attacks against the U.S. forces in Iraq. So they have done the first step successfully, and now are learning and training to increase the tracking range. Stealth planes do not have the same radar cross-sections, RCS, through all radar bands and mostly are optimized in the X band. According to the latest in-depth analysis of RCS of F-35 carried out by Aircraft 101, see the link below in the description, considering frontal aspect within -60 to 60 degrees, clear signs of increased RCS in S and L band can be seen. These bands are much more accurate and have much better resolution than VHF band. Better resolution in S and L bands will be crucial, as a surface-to-air missile with an inbuilt active radar or infrared seeker will have a greater chance of engagement, once the missile is guided to a relatively accurately calculated area or bubble in which F-35 will be. Even if the missile misses the target, it still can abort or disrupt the operation of the attackers. F-35 in VHF band is easily detectable at ranges more than 400 kilometers. According to Aircraft 101 analysis, the total average frontal aspect RCS of F-35 in stealth mode in X, S, L and VHF bands are 0.33, 0.61, 1.08 and 4.92 squared meter. Apart from this tactic, also bi- or multistatic radars may be helpful. One radar emits, and several others listen for a return, which can greatly enhance effectivity. Stealth planes are optimized to avoid detection from certain types of radar bands and at certain angles, but from other angles they are still more vulnerable. For instance, the engine exhaust is not as stealthy as the rest of the plane, and shielding the engine turbine and afterburner is impossible. It can be done, but only with non-afterburning subsonic planes, not with the F-22 or F-35. The compressor can be shielded by a S-shaped, ram-coated inlet duct, but not the exhaust, so enemy fighter planes or various types of ground-based sensors have a chance to pick up F-35 signature. The same goes for the radar dish at the front. Radar antennas make a good reflector themselves, and they are difficult to hide. The F-35 minimizes that problem, but doesn't solve it. Its antenna is a fixed flat plate, it's canted upwards at 35 degrees, and surrounded with ram, but the flat plate can still be seen. Depending on the angle, the return will be weak or strong, but the strong return will only be in a small angle. It makes stealth planes momentarily visible on radars, but difficult to track. However, it gives good clues where to intensely search. Also, these days nearly all military assets have become vulnerable to hacking and other electronic attacks that may disrupt virtually every aspect of military operations. Apart from this, stealth planes depend on good intelligence, so a counterintelligence effort will certainly help. Stealth planes were originally intended to operate by themselves, but in reality, they do need SCAD and EW, meaning suppression of enemy air defenses and electronic warfare support, as well as tankers. Attacking those will make life difficult for stealths too. To achieve this, long-range air defense missiles are necessary, and Iran already showed with Sayed-4B surface-to-air missile with a range of more than 300 kilometers to be capable of producing such missiles. Highly likely Iran is in possession of longer-range surface-to-air missiles. So an attack on tankers several hundred kilometers away is definitely possible. Stealth planes have to reveal their presence during a bombing run. If they use guided bombs, then logically they have to be within a certain area, and in many cases they have to choose a certain flight path to get away from there. This is how two F-117s were hit over Bosnia. Therefore, it is very unlikely that the Americans will dare to penetrate Iranian airspace, in particular due to passive electro-optical detecting and tracking systems. Americans will probably try to inflict damage with long-range standoff missiles outside Iranian airspace borders. To counter this scenario, the Iranians have been preparing to defend against a large number of incoming missiles with a whole range of newly designed air defense systems. In general, better tactics, more and improved equipments and better connectivity as well as sensor fusion using the entire electromagnetic spectrum will at least partly, if not more, negate the advantages of stealth. Stealth can be compared to the low-flying tactics that were adopted by NATO during the 70s. It rendered most Soviet radars useless, and forced the Soviets to invest heavily in AWACS planes, new radars and missiles. In essence, it's a way to get an advantage on an adversary until he has found ways to counter it. These ways may be very expensive and even barely affordable, until they become more widespread and cheaper, which is indeed the case in Iran. Simultaneously, other developments such as digital radar jammers with artificial intelligence are becoming more important, as are real-time secure networking, improved tactics, and several other factors. All in all, Iran has an absolutely high chances of shooting down the U.S. stealth fighter jets of the 5th generation penetrating Iranian airspace, and a good kill chance outside it. It will not be easy, but after the advances in radar and air defense systems, especially in the last decade, nothing is impossible, and they seem to be prepared for the worst case. In the end, one has to say defending is always much harder than attacking, and without any doubt the best defense against any advanced military opponent is offense, and that is, not waiting for the enemy to attack you. Surely this will be one of the Iran's main aims and goals in the day of great event. Thanks for your attention, and see you next time.